Hello students, welcome to SR Concepts. I am Ravi Verma and in this video we will do certain calculations on mole concepts. We will also revise what we have learned so far. So at the end of this video, most of the doubts regarding mole concepts must have been cleared. So dear students, first of all we should revise, we should recall what we have learned regarding the mole. Dear students, we know that mole is a unit of amount of a substance. So mole is a unit of amount of a substance. In fact, this is the SI unit of amount of a substance. And how much is 1 mole? 1 mole of any substance is that amount of the substance which contains exactly 6.022 into 10 to the power 23 elementary particles or fundamental particles of that substance. What are elementary or fundamental particles? These are those particles which naturally exists and which naturally compose that substance. Means, for example, if we talk about carbon, this is an element and this exists in the form of carbon atoms. And if we talk about hydrogen gas, then the hydrogen gas exists in the form of hydrogen molecules. So for example, when we are talking about 1 mole of carbon, right, then it means 1 mole of carbon atoms, because carbon exists in the form of atoms. And this amount, 1 mole amount of carbon will contain 6.022 into 10 to the power 23 atoms of carbon. Okay, now one advantage with 1 mole is that the mole of any substance, 1 mole of any substance has a fixed mass. Always it has a fixed mass which is called molar mass, and the molar mass of any substance is calculated by the help of atomic mass or molecular mass or formula unit mass we have already discussed. For example, if we want to know the mass of 1 mole of carbon, that is molar mass of carbon, right, then what we need to do, as we know that carbon exists in the form of atoms, so we will take the numerical value of atomic mass of carbon, that is 12 unit, right. So we will take the numerical value of atomic mass and we will simply put the unit G in place of U, right. So 1 mole of carbon, the mass of 1 mole of carbon or molar mass of carbon atoms is 12 gram, because atomic mass was 12 U. In the same way, if we talk about 1 mole of hydrogen atoms, then it will contain 6.022 into 10 to the power 23 atoms of hydrogen, and molar mass of hydrogen atoms should be 1 gram. How did we reach this conclusion? We know that atomic mass of hydrogen is 1 U, so we will change the unit from U to G, right. So 1 gram of hydrogen atoms means 1 mole of hydrogen atoms, right. And if we talk about 1 U hydrogen, that means only 1 atom of hydrogen. Okay, again, for anything 6.022 into 10 to the power 23 particles means 1 mole of that substance or 1 mole of those particles, and their mass can be calculated from the relative mass of those particles in grams, right. So dear students, lastly what is written here, 6.022 into 10 to the power 23 number of molecules means 1 mole of molecules, that means molecular mass in grams, if it's mass we talk about, right. So once we have clarified each and every concept regarding the mole concept, right, so let's reach certain calculations. We will do certain calculations here. For example, calculate the number of moles for the following. So we have been given certain data here, and we have to calculate the number of moles. For example, we have been given 52 gram helium, 52 gram helium gas, and we have to calculate the number of moles. So dear students, if the total mass is given and we have to find out the number of moles, what we can do, we can divide the total mass of the substance from the mass of 1 mole, so that we can calculate the number of moles. First of all, we will have look at these uh, expressions. Number of moles is denoted by n, given mass of any substance is denoted by small m, molar mass by capital M, given number of particles by capital N, and Avogadro's number, that is 6.022 into 10 to the power 23, is expressed by Na. So this Avogadro's number is also called Avogadro's constant. So let's do the first example here. Dear students, atomic mass of helium is 4 unit. That means molar mass of helium atoms should be 4 gram. What we did, we simply changed the unit. Now once we have known, we have come to know the molar mass or the mass of 1 mole of helium gas, we will simply put a formula, that is the number of moles is equal to given mass upon molar mass, right? So small n equal to small m upon capital M. The small m, that is the given mass, is 52 grams. We know that there are 52 grams of helium gas, right? And we know that 1 mole is 4 gram. So molar mass is 4 gram. We calculated, and the final number, that is 13, is the number of moles. So we know that 52 gram helium has 13 moles of helium atoms. Now look at the next question. The question number 2 is 12.044 into 10 to the 23 number of helium atoms are given here. Now here we know that the number of atoms is actually given. The actual number of atoms is given. We can say the number of elementary particles is given, and we have to calculate the number of moles. Okay, so dear students, if total number is given, and if we divide this total number from the number of atoms present in 1 mole, right, then we can calculate the number of moles. So let's reach the solution. Here you can see what we need to calculate. We need to calculate the small n, that is total number of, that is the number of moles, right? And here you can see the total number of atoms is given, and number of atoms in 1 mole we already know. We know that 1 mole contains this much number of atoms. So the number, this formula, we will use this formula. The number of moles is equal to given number of particles divided by Avogadro's number, and you know that Avogadro's number represents number of particles in 1 mole, right? So small n is equal to capital N upon Na, that is Avogadro's number. We will put this number. This is the number of atoms as given here, 12.044 into 10 to the 23 number of helium atoms, right? We will divide this total number of atoms from the number of atoms in 1 mole, and finally it will come to 2. So we know that if this much number of atoms is given, that means there are 2 moles of helium gas or helium atoms. Now let's reach the example number 3.4. Example number 3.4. So dear students, look what we need to calculate. We need to calculate the mass from the given quantities, right? Here you know in question number 1 what is written, 0.5 mole of nitrogen gas, or we have to calculate mass from the moles of molecule. So dear students, what we are given with, we are given with the total number of moles, that is 0.5 mole of nitrogen gas, right? And we have to calculate the mass. So if we multiply the number of moles with the mass of 1 mole, then we can calculate the total mass of the substance, right? So dear students, what is written, we have to calculate the mass, and what we can do, if we anyhow get to know the molar mass of the substance, we are already given with the number of moles of nitrogen, that is 0.5. So dear students, how we will do this? We have to use this formula, total mass is equal to molar mass into number of moles. Number of moles we are already given with, we have to calculate the molar mass. We know that nitrogen exists in the form of nitrogen molecules. So in order to find out the molar mass of the nitrogen gas, we have to know the gram molecular mass. For gram molecular mass, we need to know the molecular mass. And we know that the molecule is made up of 2 nitrogen atoms, and atomic mass of nitrogen atom is 14 U. So the molecular mass will become 14 U into 2, that is 28 U. But as we have to get gram molecular mass, so we will put the unit gram here, so it will become 28 gram. So this is how we calculate the molar mass of nitrogen gas. We know that molecular mass is 28 U, so the molar mass will become 28 gram, means one molecule has mass equal to this one, and 1 mole of molecules has the mass equal to this one. Now as we know the mass of 1 mole, that is molar mass, and we know the number of moles also, so the total mass we can calculate, right? We have 0.5 moles of nitrogen gas, and each mole has 28 gram mass, that means the total become 14 gram. So if we have half a mole of nitrogen gas, that means we have 14 gram nitrogen gas. Okay, now here you can see what is written, 0.5 mole of nitrogen atoms. So here the mole of atoms is given, not the mole of molecules of nitrogen. This need to be noted, that here they have written 0.5 mole nitrogen gas, and here they have not expressed, they have not means specified the particle, they have written nitrogen gas only. They neither written atom nor the molecule, but here they have written nitrogen atoms. So here we need to use our wisdom, that nitrogen gas exists in the form of molecules, that means they are talking about nitrogen molecules. But when they have specified nitrogen atoms, then we should know that they are talking about 1 mole of nitrogen atoms, right? So again we will do the same thing. We have to calculate the mass. We are given with number of moles, we need to calculate the molar mass of nitrogen atoms. For calculating the molar mass of nitrogen atoms, we need to know the gram molecular mass of nitrogen atoms. We know that gram atomic mass of nitrogen atom, and we know that atomic mass of nitrogen atom is 14 U. So gram atomic mass will become 14 gram. So molar mass of nitrogen atoms will become 14 gram. Now let's put this value here. After putting this value, small m is equal to capital M into n, 14 into 0.5 mole, that becomes 7 gram. Now again look at the next question. Question number 3rd. 3.011 into 10 to the 23 nitrogen atoms are given, and we have to calculate the mass of these atoms. Dear students, again we have calculated the mass from the number of moles. If we calculate the number of moles from the number of atoms, we will easily calculate the total mass. So what is given here? Let's look at this. The number of moles, small n, is equal to number of particles upon Avogadro's number. We are given with nitrogen, we are given with the total number of nitrogen atoms, right? So the total number of nitrogen atoms here, and Avogadro's number is here, right? We get the total number of moles, that will become 0.5 moles, right? We have to calculate the mass, so we will put this formula. mass is equal to, means the given mass or the total mass of the nitrogen atoms equal to molar mass into number of moles. We have already calculated the number of moles equal to 0.5 mole. The mole is always expressed by mol, not by mole. So this much is enough to symbolize the mole, right? So we have calculated this. Molar mass of nitrogen atoms is 14. Number of moles we have calculated 0.5. So the answer becomes 7 gram. Right. Now look at the next question again. 6.022 into 10 to the 23 number of nitrogen molecules, and we have to calculate the mass. We know that this much number is 1 mole of nitrogen molecules, so the molar mass will become the total mass of the substance, right? Once again, let's look at this. So first of all, we will calculate the number of moles from the total number of molecules divided by Avogadro's number, right? And we will calculate the mass by using this formula. Molar mass into capital N upon Na, right? So we will put this value and we will get 28 gram, right? Now let's look at the example number 3.5. Calculate the number of particles in each of the following. Okay, so we have been given 46 gram of sodium atoms, that is we have to calculate the number of particles from the given mass. So dear students, how we need to change it? We have been given with mass, the total mass. We need to calculate the number of particles, and how we will convert it? We will convert first of all mass into number of moles, and then number of moles into number of particles. So how we will do this? Look at the solution. Look at the solution, how we have done this. So total number of particles, that is capital N, is equal to given mass upon molar mass into Na, right? So how we do this? We have put this total mass upon molar mass. This will give you the value of number of moles, and if we multiply this with the Avogadro's number, we will find out the total number of particles, that is capital N, equal to 12.044 into 10 to the 23. So this is very simple and easy. Once again I will tell you what we have been given. We have been given total mass, that is 46 gram. So if we divide it with the molar mass, right, that is 23 gram, right, 23 gram. So this is the total number of moles is 2, and we will multiply this total number of moles with number of particles, that is 6.022 into 10 to the 23. This is the Avogadro's number. So this is how we will get the total number of particles from the given mass. Here you can see what is given, 8 gram of oxygen molecules. So again we have been given with the mass, and we have to calculate the number of molecules. Again, first of all, we will convert the mass into number of moles, and number of moles is equal to mass upon molar mass, and then we will this will give you the value of number of moles, right? This will give you the value of number of moles, right? And we will multiply this with Avogadro's number. So they have done this here. Here you can see we will use a simple formula. We have made this formula, number of molecules equal to given mass upon molar mass, that is equal to actually the number of moles, and we will multiply it with Avogadro's number. So here is the value. We have put the mass, that is 8 gram, molar mass is 32 gram, into Avogadro's number 6.022 into 10 to the 23, and the number of atoms becomes 1.51 into 10 to the 23. Look at the next solution. This is again we are given with actually the number of moles, and we have to find out the number of particles. So this is very simple. This is very simple and easy. Here you can see how they have done. Number of particles is equal to number of moles into Avogadro's number. Number of moles is 0.1 gram. Avogadro's number is 6.022 into 10 to the 23. So finally it becomes 6.022 into 10 to the 22, right? So I hope you got these calculations, and there are no doubts in your minds. Even if right now you have any doubts, you can ask me during the online classes. Thank you for watching this video.